Now, one of the very nice things about linear functions is that every linear function is one-to-one, and its inverse is also a linear function. And this is easy to see by thinking about the graph. We can tell that it's one-to-one because of the horizontal line test. That is, any horizontal line will only cross another line one time, because lines can only intersect at one point if they're different lines. And the graph of an inverse is a reflection of the graph of the original function. Of course, if I reflect an oblique line, I get another oblique line. And so just thinking about the graphs and what we know about the graphs of inverses and the graphs of one-to-one functions, it's easy to see that every linear function is going to be one-to-one, and its inverse is also a linear function. By the way, this is part of why we wanted to exclude constants from being linear functions, because obviously those are not one-to-one. So let's see an example where we have to find the inverse of a linear function. As always in finding the inverse, our first move is that swap x and y move. Right, so f of x is something in x. We write x is that thing in y. And then I'm going to swap the order because I want y to be on the right. So I've got 2y minus 8 is x. And here I'm using the fact that equality is symmetric. Now I'm going to add 8 to both sides. And I'm going to divide both sides by 2. And finally, in order to make this look linear, in order to get this also in the form y equals mx plus b, I'm going to distribute that division. So I've got y equals x divided by 2 is going to be a half times x, plus 8 divided by 2 is 4. And so in function notation, I have f inverse of x is half x plus 4. Let's see another example where the arithmetic is a little bit more unpleasant. This is basically the same. We're just seeing a second example. Here we have f of x is 2/5 x plus 7. And again, we started with that swap x and y move. And again, next I'm going to switch the order. Right? So I have 2/5 y plus 7 equals x. And you could do these at the same time if you felt like it as well. Now I'm going to subtract 7 from both sides. And now, to get rid of the 2/5, I think it's nicer to think of this step as multiplying both sides by 5/2. So on the left, I'll have 5/2 times 2/5 y is 5/2 times x minus 7. And the 5/2 times 2/5 cancels out. And so I'm just left with y equals, and then on the right, we need to distribute 5/2 x minus 5/2 times 7 is 35/2. And so again, going back to function notation, f inverse is 5/2 x minus 35/2. Now, it is the case that there is a pattern to the slope and intercept that we find in the inverse. And if you need to find the inverses of thousands of linear functions, it might be worthwhile explicitly writing down that pattern and memorizing it. But the process involved in taking the inverse of a linear function is pretty straightforward, not very time consuming, unless you have to do it a whole lot of times or teach a computer how to do it. It's really easiest, rather than memorizing the general form, to just go through the process each time.